Review assignment number 5. You're given a function. You should do it on a separate piece of paper. You're given a function. First step, find the zero. So make it equal to 0, factor it. So two numbers that multiply to 2 and add to -3. The zeros here are positive and -1. If I take x squared minus 2 equals 0, I add 2 and square root, and I get positive and negative root 2. So we have 4 zeros, positive and -1, and positive and negative root 2. Part B, write an equation of a line tangent at x equals 1. So we have x equals 1. For y, we plug in 1, and I get 0. And then to find the slope, I take the derivative. So that's 4x cubed minus 6x, and then the derivative of 2 is 0. And then plug 1 in, and you get 4 take away 6, and then put this together. I don't need to go plus 0 at the end. For part C, find the x-coordinate of each point at which the line tangent of graph is parallel to that. So y equals -2x plus 4. The slope is -2. So if I take the derivative, which is the slope, and make it equal to -2, these x values will tell me where that is. And that's where you can use your calculator. So I'm going to go on menu, algebra, and solve, and type in 4x cubed, subtract 6x, equals 2, -2, comma x, and then solve it. So I get -1.366. I got 0.366. Now, see how there's like a little arrow there to the right? Like it's telling you highlight it, push it to the right. There's one more answer maybe that you didn't see. And so 1 is the last answer. So make sure you get all 3 answers. So if you see a little arrow there, highlight and push it over so you can see all the answers. And there it's done. All right, the next one. A particle moves along the x-axis so that its position, and we're going to use a calculator here, is sine pi t squared between -1 and 1. That's going to be important. And then we're going to do a few things. So find the velocity. Well, I don't need a calculator for that. The rule for sine is cosine, copy. And then the hook, the derivative of this is 2 pi t. So 2 times pi, and then subtract 1 to the exponent. The hook is 2 pi t. Part B. Find the acceleration. So let's do the derivative again. Now it's going to be the product rule. So it's the first times the derivative of the second with the hook plus the second times the derivative of the first. The derivative of 2 pi t is just 2 pi. Part C. For what values of t does the particle change direction here? So I'm going to take the velocity, 2 pi cosine pi t squared, and make it equal to 0. And I'm solving between, and I'm going to show you how to do that with your calculator. I'm going to solve between -1 and 1. So let's do that together right now. Hopefully, the camera and the calculator sometimes gets a little whatever when they see how the calculator doesn't quite know what to do with it. But anyways, or the camera. We can go menu, algebra, solve. I'll get there. And so the equation is 2 pi. I'm going to use t and then cosine pi t squared and that's equal to 0. Now, if I just do that, the answer is not going to be pretty because there's an infinite number of answers. So I'm going to go control and then equals, and then I'm going to go to this line, and this allows me to put in a restriction that goes from -1 to 1. So I'm going to write down -1, control equals less than or equal to, and then t, control equals again, less than or equal to, there it is. And so I was able to put a restriction in. So when I go control enter, it's only the answers. Oh, what did I do that I didn't like? All right, let's try it again. I think I know what it didn't like. Okay, so I'm going to go, I think I didn't like this part right here. I just had a feeling. It wants to times. Let's see if that makes a difference. So I'm solving it. How did I not type that in right? 2 pi t. Wait a second. Well, the one answer is good. 0.707. Okay, so 0.707 is a good answer, and 0. I'm not sure what that middle part, I don't like it all, so I'm ignoring it. So 0 is an answer, and 0.707. See how the N107, I'm not going to, so 0.707 is what I was looking for, and 0. Going with it. Those are the two answers I'm looking for. And then, if we put this on a number line, between -1 and 1, if I put them in order, what are we looking for? Oh, when do they change direction? You know what? I'm even going to do the graph. Let's do the graph so I can see it. It's going to be easier. So I'm going to go menu, actions, and delete this. I'm going to go change the window already. So I'm going to change the window so it's -1 to 1. The rest is fine. Then tab, I'm going to type it in. So make sure I type it in right, which is, and I'm going to use x. So 2 pi x times cosine pi x squared. Let's hope this graphs. Awesome. So we already have some values there. Oh, it's positive and negative. So, in fact, let's do it right here. So, I missed a 0, right? So, analyze 0. It's much easier off the graph than what I just did. So, if I move this to the left, I want to know where it crosses the axes. So, here and here, it's negative 0.707. It's 0, and on the other side is positive 0.707. And go, where does it change direction? So every time it crosses over, it changes direction. So it changes direction at all of it. And we can say the velocity right, or changes signs there, so we can see it's above or below. All right, part D. It says find all values of where it's moving to the left. So it's moving to the left when it's below. So it's going to be below from negative 0.707 to 0. And where else is it below? Is from point to 1. So 0.707 to 1. It's because these are negative, it's moving to the left. If it's positive, it's moving to the right. All right, a particle initially at rest moves along the x-axis, so its acceleration is 12t squared minus 4. So A, where is it, when is it, oh, and it gives you some values. And the position of the particle is is 3. All right, so if we find the velocity, we're going to integrate this. So we're going to add 1 to the exponent, and when you divide, and then plus c. So when it says initially it's at rest, that means that when you plug in 0 for t, the answer is 0. So that means c equals 0. And then when is it also at rest? So when it says particle initially at rest, it means that the velocity equals 0 when t equals 0. That's what that is. Then it says find the values for the particle is at rest. So we're going to make it equal to 0. We're going to factor this, just 4t. And then solve it. So we have 0, positive 1. Now, negative 1 I'm going to cross out. So in the question it says t is greater than or equal to 0. So the negative value would cross out. So these are the 2 times where the velocity is 0. Part B, find the position. So I'm going to integrate. That means I'm going to, is it s? X. So we're going to add 1 to the exponent, 4, and divide. So that's just t to the 4. Add 1 to the exponent. When you divide, it's 2. And then plus c. And then in the question it says when the time is 1, the position is 3. So I'm going to plug in 1 and solve it. So 1 take away 2 is negative 1, and then add 1, and it's 4. So here's the position, t to the 4 minus 2t squared plus 4. And then part C, find the total distance between 0 and 2. So because it changes direction at 1, so if this is the velocity, if I plug in 1/2, it's negative, but if I plug in 2 or 3 or 4, and so because it changes direction, I want to find the total distance. We need to set it up twice. Oh, could you use your are you allowed to use a calculator for this one? You are. So because you're allowed to use a calculator, I guess I could have used that all along. To find the total distance, this is a good thing to know. We are going to integrate the velocity from 0 to 2, but it's the absolute value of the velocity. So the absolute value of this will give me the answer. All right, use your calculator. The absolute value makes all the areas positive, and then you just add, this is what it does. Integration adds up all the areas. So menu calculus integrate. Oops. And we're going to integrate from 0 to 2, and it's the absolute value. of the velocity. And I get 10. And there you go. All right, halfway there or more. 2 left. Let R, so a calculator is allowed here. We're given the equation x over x squared plus 2 from 0 to the square root of 6. So find the area of the region. So we're going to integrate from 0 to that, x over x squared plus 2. That's going to give us the area. We don't have 2 equations, so we're not worried about top subtract bottom. All right. We just have the 1, so it's just the top. The bottom's like 0. Menu, calculus, integrate. So from 0 to root 6. And then go control divide, x, and then in the denominator, x squared plus 2 dx. And you get 0.693. Next, if line x is equal to k, and it divides the region into 2 equal areas. So, first of all, 0.693 divided by 2, I won't even put that answer down, but I need to know that's half the area. So when I integrate from 0 to k, x squared plus 2, it's equal to 0.693 divided by 2. What is that value of k? So there's the setup. So again, I'm going to go menu, calculus, integrate. And 0, I'm going to use k. And control divide, x over x squared plus 2. Oh, you know what I forgot? I need to solve it. So let's start at the beginning here. And then go menu, algebra, solve. So we're going to solve this equal to, what was it, 0.693 divided by, oops, how would I want to do? There we go, equals 0.693 divided by 2. There it is, comma k. And so towards the positive direction, right? Because we're going from 0 to root 6, so not the negative value. It's 1.414. Part C. What is the average value? That's an integration question. From 0 to root 6. And then you divide by the difference of the bounds. That's it. Just type that in. Let's do it together. So control divide for the fraction, and then calculus and integration. It goes from 0 to root 6. Oh, we already did that, right? So you know what I could, anyways. It's fine. I'll type it all in. I actually already know the answer in the numerator. Like, the numerator is already here, so I just need to take that number divided by root 6. But here it is. And I get 0.283. And again, instead of retyping this in, that is the first. I could have just went, and then, you know, when it's a test, it matters this time. I could have just went like that divided by root 6, right? And I would have got the same answer, 0.283. So this is a 3. 0.283. All right, one left. Let f be the function, f at x equals the square root of x minus 3. So first of all, sketch this. This is no calculator. So if I sketch this, the square root of x, I know what that looks like. Subtract 3 means it moves 3 to the right. When it's under here, it goes the opposite direction. So 3 to the right, and then draw your square root function. Sketch the graph of f and shade the region enclosed by that graph, the x and the vertical line 6. So 4, 5, 6 right there. And then shade that area in right there. Find the area of that. So that's part A. That's an integration question from 3 to 6. So if I write this calculus friendly, there's no hook involved at all. So I just have to add 1 to the exponent, which is what, 3 over 2, and then divide, or the reciprocal, from 3 to 6. And I don't need to simplify this, so I'm going to plug in 6 first, subtract, and then I'm going to plug in 3. That's a 0. So this is my answer right there. Part C. Rather than using the line x equals 6, consider the line x equals w, where w can be any number greater than 3. Let AW be the area of that region enclosed by the graph of f, the x-axis and that vertical. Write an integral expression for A. So A at w is an integral from 3 to w, whatever that number is, not 6 anymore. And then it's f at x dx. Then part D says find the rate of change. That means find the derivative of this. Now what's going to happen with the derivative and the integration? This is the fundamental theorem of calculus, and this ends up being a substitution question. Now the denominator, when you do that, it's just going to be 0. But the numerator, I'm just going to plug that directly into the equation. So it's going to end up being the square root of w take away 3. So it just becomes a substitution question where you take out the x and put in w. That's it. All right, Mr. G Math over and out. Great job doing your work for today. Until next time.